Do you want to understand electricity? Do you also have questions like what is it or how does it work? Then this tutorial is for you. I will try to explain it from scratch, so let's go. Now everyone knows periodic table from chemistry subject, right? All known elements are put there with their specific characteristics. For example, Helium put in second because its atomic number is 2. Wait, atomic number? What is atom anyways, you might ask? Well, atom is smallest particle of every element, which means they make all the matter around us. Atom consists of core and electrons orbiting around it. Core consists of proton and neutrons. The mass of proton is roughly equal to mass of neutron. The charge of proton is exactly equal to charge of electrons, and charge of neutron is 0. Atomic number on periodic table represents number of protons and number of electrons. They are always equal to each other. For example, in hydrogen atom, there is 1 proton, 1 electron, and 0 or 2 neutrons. So if we kind of draw hydrogen atom, it would look something like this, where in the core there would be 1 proton and 1 electron orbiting around it. Proton's charge is positive and electron's charge is negative, so total charge of atom will be 0. We need to learn this, because electron configuration of atom related to electricity. Now, in order to explain electricity, I might do some analogy and it might not be 100% correct. But just for understanding basic level, we need those simplifications. If you want to understand them fully, you will be lost in quantum physics. Anyways, so let's draw an atom. There is core with some number of protons and neutrons, and there is electrons orbiting the core, for example in sphere shape, dumbbell or like figure 8 shape. And there could be multiple instances of specific shapes. Each shape have 2 electrons or pairs of electrons. Well, it turns out electrons does not just orbit core randomly. It actually follows certain rule. And those rules actually fun to learn, so let's begin. First of all, let's learn orbitals and shells. Orbital is shape of electron path, or we can call them figures, like spheres or dumbbells as I mentioned. There are 4 orbitals named S, P, D, and F. And shell is energy level of electrons, or in other words, we can say floors of electrons in atom. And we can number the floors like 1, 2, 3 and so on, right? Let's draw a simple table for orbitals. First, let's talk about difficulty level. Imagine it as complexity of the shape. So S is simplest shape, just a sphere, so we give it 1. P is kind of complex, it's like some figure 8 shapes. D is much harder to explain. F is even harder to explain. Even in 3D it's very weird shapes and we cannot compare it anything exists in nature. Okay, now we don't care about those shapes, all we care is their ability to hold certain number of electrons. And let's call them pairs because every shape in orbital holds 2 electrons, or in other words, every 2 electrons makes certain shape in orbital. S have just 1 shape, so just 1 pair. P have 3 shapes in X, Y, and Z axes. D has 5, and finally F has 7 shapes. So total electrons of orbital is the number of shapes multiplied by 2, because remember, each shape holds 2 electrons. P have 6, D have 10, and F have 14. Now let's make a cheat sheet for orbital configurations. So first shell will be 1s2, it means 1 is shell number, S is orbital, 2 is total number of electrons on this orbital. So there are 2 electrons in S orbital in the first shell. Okay, now in second shell there will be also S shape, but we write it as 2s2, and there is P orbital as well, we write it as 2p6. So in other words, in second shell there are 2 electrons in S shape and 6 electrons in P shape. And the trend continues like this. 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d10, 5f14. From there we will go backwards like 6s2, 6p6, 6d10, 7s2, 7p6, and lastly 8s2. Let's put that in here and do an electron configuration for some element. It has atomic number of 28, which is nickel by the way. We look at cheat sheet and go from top right diagonally. So we start with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and let's stop here and count the electrons. So 4, 10, 12, 18, 20, 30. Well, it's actually more than 28. In that case, we just remove some electrons from last added orbital. Keep in mind here, we don't take it from last shell. So 3d10 becomes 3d8, and that is electron configuration of nickel. Okay, now you might be asking questions like why I need this. Well, the definition of electricity is flow of electrons on the last shell. Because last shell electrons can actually jump to neighbor atom. It's weakly bound to the core. Other electrons will not jump because their shell is full and they are much closer to the core, and in other words, tightly bound. Okay, so we need all this just to know if last shell is full or not, and that explains electrical property of material. And now let's do analogy to explain it simpler. So, imagine like cone-shaped dish, like ice cream cone-shaped dish, then fill it with balls. Fill more and more and more and more, all the way to the top. Now imagine each ball as an electron and each layer of ball as a shell, and all of this as a single atom. As shell number increases, number of atoms we can put in that shell also increases. Now imagine some element atom with last shell is full or cone-shaped object is full, and second element's atom has only one electron in its last shell. This one electron can move freely, right? And third type of element's atom is having couple of electrons but not full, so you can move freely only in extreme conditions like shaking the cone, also which can be represented as heating the element. Now let's tilt the first cone. Since all electrons on the last shell is tightly placed, so they cannot move, so nothing happens. But for the second cone, electron can actually move and leave the cone if we tilt enough, and it will go right next to neighbor atom or cone in our analogy. For the third one, as we tilt, electrons will try to escape, but we need to tilt it even more to actually make electron jump. Those electrons jumping is electricity, and elements can be categorized by ability of passing electricity or conducting. The first example being non-conductor, the second being conductor, and third being semiconductor. Let's add those words to learn stack. Now you can imagine amount of tilting on those cones as potential applied. For example, 1 volt for small tilt, 2 volts for more tilting, and 3 volts for even more tilting, and so on. Now let's take a slope and fill slope edge with cones near to each other. That's actually how conductor atoms are placed, by the way. Let's assume lowest level of slope as potential 0 and highest level of slope as potential 1. And they could be like 0 volt and 5 volt, for example. So difference between those potentials is actually represents voltage applied to the material. As the voltage increases, or in other words slope degree increases, last shell's electron in the atom or last layer of balls in cone starts to move down, right? And that represents electricity. Now let's take a small section and count number of electrons passing in that section per second. We can say number of electrons as charges passing in that section per second, or charge flow rate. This represents current. And lastly, surface parameters of material. It could be surface roughness or surface area. They represent resistance. So resistance of material depends on material type and surface area. Now let's make a table for those three to explain. First, voltage. Its symbol is V, unit is volts, and it can be represented as like 3.3 volt. Next, current. Its symbol is I, unit is amps, 100 milliamps for example. Resistance. Its symbol is R, unit is ohms, 1 kilo ohm for example. Those three makes fundamentals of electricity, and they even related to each other. current, for example, proportional to the voltage applied, because as we increase slope heat, number of atoms passing will also increase, right? And current is also inversely proportional to the resistance, because no matter how much you push by increasing slope heat, current will not pass if surface is rough. And those will make golden rule of electricity, called Ohm's law. And finally, that's all I wanted to explain. Here are the stake of knowledge we took from this course, and thank you for your time. See you next time.